So on that note, we did kick off in our previous lesson, and there were a few little roadblocks that we hit as we went along, but we started differentiating. The basic rule, let me find that lesson. So, we did all of this. We had such a productive lesson as well, because we did all of this stuff with differentiating. Just a reminder that we take the power when we differentiate and find the derivative, and we times it by the coefficient of the variable, and we subtract 1. So we were very busy last week, Thursday, with doing that. So today, just to remind us of that, I just want you to do these 3 sums in the warm-up. Remember, our basic idea is to not have any algebraic fractions and no roots. So we first need to, before we differentiate, we always first need to manipulate our expression and then differentiate. Manipulate it so that there are no algebraic fractions, so no x's or variables in the denominator, and also no root signs. Okay, so I want to see how much you remember from Tuesday's lesson. So please give these first 3 questions on the board a go as a warm-up, and we'll check back in here. 3 questions, 3 minutes. We'll check back in here at about 12 minutes past, see how you are doing. Okay, off you go. Remember to post your answers in the chat as soon as you're ready. Well done, Kolofelo. We've got 1 answer so far. Let's see if anyone else has an answer for us. Maybe for number 2. Itumileng's got answers. Well done, Itumileng. Itumileng, check your question B. You've got it right, but you haven't differentiated yet. So make sure that you differentiate. You've rewritten your expression perfectly in the right form, but now you must just differentiate. Hope, well done. Hope's given us an answer for question B or question 2. Okay, let's wait for a few more answers and then we can post them on the Primrose is doing C for us, I think. Okay, there's Hope. Hope's got C, and Tamika's got question C. Nice. That looks good. Okay, let's have a look at our answers. So for the first one, no need to change anything. We have 3/4 as the coefficient of the x squared. So we're going to times our 2 with the 3/4. So 2 times 3/4, that's what we're going to do, and then subtract a 1 from the exponent. So 2 times 3/4 is going to give me 3/2 x to the power of 1. Okay, I don't see many confirmations from the chat. I hope everyone's awake and working with us. So for question 2, we have to first rewrite our expression so that x to the power of 2 is above the line. So to do that, we're going to make that f of x is 5x squared over 2. And then we're going to differentiate. So we're going to times the 2.
Ma'am, don't forget that 5x to the power -2.
Oh, thank you, Miss Coco. There we go. Sorry, yes, to the -2. We can't just move it to the top.
Yeah.
Okay, so we're going to times the -2 by the 5. And that is going to be -5x to the power of -3. Yeah, good stuff. But let's just get our notation right here as well, because that is not quite the same thing. We have to differentiate. So f dash x is -5x to the -3. Okay, and then for question 3, this one we also need to rewrite first because we've got that root. So remember, we take the inside power over the degree of the root. So we go 2/3. Solomon also missed the negative. Don't worry, Solomon, we all do that. I did that too. So f dash x, or the derivative now, we're going to take the 2/3 times it by the 1 that is in front of the x and subtract a 1 from the 2/3. That's going to give us 2/3x, and subtracting 1 from 2/3, I just get my calculator here so that I don't make a mistake, that gives me -1/3. There we go. Okay. Who got all of those right? Anyone? I do see some people. Some people got the last one right. Very nice. Very nice indeed. So well done, everybody. Solomon, next time you will definitely remember the negative. Okay, so we're going to take this further tonight, and we're going to differentiate some more. And we're just going to start by looking at these 3 expressions. Now, we've got more than one term, and I'm going to do number A with you. Just start off first. And important here, we read the question, it says determine dy by dx. So dy by dx means when we differentiate, we must say it's dy by dx. So not f dash x or any other notation, we must use dy by dx. So if we look at this first question here, now this, up to now, we've only really done one little term at a time. Now we've got polynomials, but basically the rule says you can just differentiate. If there's a polynomial, you differentiate each of the terms individually, but you have to do it all in one step. Okay, so you can't differentiate one term and then the next step differentiate the other term. All the terms must be differentiated at once. So for this one, we're going to say dy by dx. We check there are no fractions with x's in the denominator, and there are no roots, so we're good to go. So we're going to go 2 times 3 is 6x. From the 2, we subtract a 1, so that's just x to the power of 1. Then for the next one, we're going to take the power of x, times it by 2, that gives me 2. And from the x to the power of 1, we subtract a 1, that gives me x to the power of 0, which is just 1. And then a -5 differentiated is just a 0. Okay. Now, before I start question B, I'm going to give you a chance to think about this on your own quickly for 2 minutes till 20 past 5. And if you're ready to differentiate it and give it a go, you're most welcome to. Otherwise, for those of you who are still getting used to differentiation, you can just try and write this in the correct form with all the x's above the line, so no x's in the fractions and no roots. Okay, so let's take till 20 past to try and figure that out, and then we'll see what the answer is. And as always, don't be shy to put your answers in the chat. Okay, so let's see. The chat's very quiet, so I'm wondering what is happening. What are you guys thinking? Please share your thoughts. So x to the power of 3, that can stay as it is. Then we need to take the x squared that's in the denominator. We need to take it above the line and make it x to the power of -2. Now, this here, the square root of the cube of x. So we are going to make it. Oh, here's an answer. Yay, Pelo, thank you. What have you got? Oh, you've differentiated already. So, okay, I'm not there yet. I'm going to catch up with you just now. So that's going to be 2/3. And first, we're just going to make that x cubed, the square root of x cubed. We can make that to the power of 3/2. We take the inside power divided by the degree of the root. Okay, so I'm just doing it one step at a time so that I don't make any mistakes. Then that gives me 5x to the power of -2. Now the last step is to get that x to the power of 3/2 to be x to the power of -3/2, because we don't want it in the fraction. It needs to be in the numerator. And now we are ready to differentiate. So dy by dx. Pillow and Hope, well done. Let's see if you were right. So we go 3 times 1 is 3x squared. Then we're going to go -2 times -5 is +10 x to the power of -3. And then 2/3 times -3/2 is going to give me a -1 x. And then we subtract from the -3/2, we subtract a 1, and that is -5/2. Okay, so if you made a mistake with your power, I see for the last term some of you didn't factor in that it's x to the power of 3/2. So just make sure you fix that power, because it is a root, x to the power of 3, that's a square root. So just keep an eye out for that one. Sibusisu's showing us a party face, so I assume you got that one right, Sibusisu. Well done, well done. Good for you. Okay, right. So we're going to do a few of those, a few more of those in a minute. I just want us to get to these last few examples of sort of more complex expressions. Oh, you thought it was a cube root. Yeah, it's easy to mistake, okay? Because if you did think it was a cube root, then your answer was right. Okay, so just again to reinforce this, before we differentiate, we cannot have brackets, we can't have any algebraic fractions, and no roots. So we have to rewrite our expressions first before we can differentiate and get rid of those things. Okay, so let's have a look at this first one, because what we've had up to now was just sort of one variable in the denominator, and this one is still the same, but we cannot quite simplify this. We can't go x cubed goes into x to the power of 4. That would be making quite a big mistake if we did that. Okay, so be very careful when you have these algebraic fractions that you don't divide incorrectly. Okay, so that you don't go x cubed into x to the power of 4 and x cubed into or making funny mistakes like that. Okay, it's very important that if you do want to simplify this, just separate it out over the x to the power of 3, and the same over here, x to the power of 3. So just separate it out like that, and that you can still do if you've got a fraction over a fraction where there is one term in the denominator. But look at this one here, which we're going to get to question C. Here we've got 2 terms in the denominator, so that plan is not going to work here. But we'll chat about question C when we get there, and we need another plan for there. But here, what we now can do is go x to the power of 3 and x to the power of 4. That is very simple grade 8 division, right? X cubed into x to the power of 4 just gives me an x. And here, x cubed, we can subtract the 3 from this exponent here, which is a 1, so minus 3 over there. And that gives me minus 3x to the power of minus 2. And that is f of x. And now we're in a position to differentiate, right? Because we got rid of all the algebraic fractions. We didn't get rid of them, we just wrote them in a different way. But now we can differentiate, and that's going to give me 1x and then minus 2 times minus 3 gives me plus 6x, and subtract 1 to the power of minus 3. Okay. Sibusiso, just be careful when you differentiate that x, it actually becomes a 1, because you go 1 times by 1, and then you subtract 1, which leaves you with x to the power of 0, and that is 1. X to the power of 0 is just a 1. Right. Okay. So let's have a look at question B as well, because it's a similar plan that we're going to have for question B. Let's give it a go. We're going to check back in about 3 minutes. Remember, if you have any questions, just let us know, pop them in the chat. We can chat to Miss Coco as well. She's the queen of differentiation. I will give a hint so far. Remember, we can separate this out. We can go 4x over x squared plus root x over x squared. See if that doesn't maybe help. And now we just need to get rid of all the algebraic fractions, so the x in the denominator. Right, Pelo, well done. You got an answer for us. I'm also going to give some more hints. Oh, Sibusiso, well done. We can subtract the x to the power of 2 and the x to the power of 1. We can subtract the powers because we're dividing. Let's just be clear about what exactly we're doing. We're dividing x squared into x to the power of 1, and we do that by subtracting the exponents because the bases are the same, which is something you learned in grade 8. Remember that this root x is the same as x to the power of a half. So we can write that as x to the power of a half, and then we can do the same and subtract the 2 from the half. So that's going to give us x to the power of minus a half minus 2 is, no, not a half minus 1, a half minus 2 is minus 3 over 2. Okay, oh, it looks like a few of you got this one. Well done. So f of x, we're going to differentiate. This gives me minus 4x to the power of minus 2. Multiply the minus 3 over 2 with the 1. That gives me minus 3 over 2. And subtract another 1. And that gives me minus 5 over 2. Hey, Ms. Coco, it looks like a few people got that one. Well done, because that was not an easy one. That had lots of steps. Well done. Well done, Itumeleng. And who else here? Hope as well. Just remember, guys, that you write f-x to show that you're differentiating. That's important. Sibusiso, Belinda, Pelo, well done, everybody. That's great work. Okay, so we are on a roll here with more complex expressions. We've got question C there. So question C, we can't break up the terms over the denominator. That's not really going to make it easier in any way. But what we can do is factorize to get rid of that denominator. So if we have f of x equal to 4x squared minus 9. Oh, Kolofelo's already got an answer here. Well done. Let's see if you're right. Then we can factorize 4x squared minus 9. So it's 2x minus 3 and 2x plus 3 over 2x minus 3. And those two brackets are the same. So we are left with f of x equal to 2x plus 3, and that is easily differentiable. No fractions, no roots, no nothing. We're going to differentiate the 2x, so it's going to be a 2, and differentiating the 3 makes it a 0. Well done. A few of you got it. Tumeleng got it. Kolofelo got it. Okay, and now lastly, we're going to do question D. That also needs factorizing. Okay, so I want everyone to try that one. We've got in the top x squared minus 2x minus 3 in the numerator. What is that? That is a, I hope everyone at home is going trinomial. Yes, so we're going to do a trinomial for this one. I'm just going to move this over so that we can see it on the side of the board. Okay. Question D, give it a go. This is the challenge of the evening, definitely. So if you get this one right, you can definitely give differentiation a tick, because then you are ready for that prelim paper, guys. It is around the corner. Okay, there we go. Okay, I'm going to leave some space here. Question D. Let's take 3 minutes for question D. And my hint for this one is factorize, factorize, factorize. And those of you who have been so quiet this evening, come on, challenge yourself. Challenge yourself. Try it. Maths is not a spectator sport. You have to get in, roll your sleeves up, get in there and try, even if you get it wrong. We've all gotten things wrong this evening. That is okay. We learn from our mistakes. So let's check in at about 17:37, see how you are doing, and post your answer when you're ready. Okay, if you have started this one and you've started factorizing, I am going to give you some support here, Kolofelo, with the little crying face. Come on, we can do trinomials. We can factorize trinomials, I'm sure. At the very least, we can factorize the bottom. So 6 minus 2x, we can take out a minus 2 as a common factor there and get minus 3 plus x at the bottom. Yeah, someone's giving me a wow face there. And at the for the x squared minus 2x minus 3, yes, we've got to be able to factorize these trinomials. So we have an x and an x, so will give us x squared. Then we look at the minus 3. The factors of minus 3, that will add up to minus 2. So that will be minus 3 plus 1. And then you should start feeling really excited and happy, because this bracket is the same as this one. Minus x minus 3 plus x and x minus 3, that is the same. You can even swap them around if you want to, but no need to waste that time because that's going to cancel out, and we're going to have x plus 1 over a negative 2. I see Itumeleng, Sibusiso, well done, and Liam, I think some of you are on to something here with your answer. Now we can make this into minus x over minus 2 minus a half. We just take this 1 and put it over the minus 2, which will make it a minus a half. And when we differentiate, we get x to the power of 1 times by this coefficient, which is negative a half. So that gives me negative a half. Subtract 1 from the exponent, so that's x to the power of 0. So no more x's. X to the power of 0, remember, is just 1. And differentiating a constant is 0. So well done, Sibusiso, Itumeleng, Liam. Anyone else at home also got that answer? Well done. Negative a half is correct. Excellent. Okay, if there are any questions, please raise your hand so that we can clear up any confusion that there might be. Now is your chance. Remember, differentiation is a new skill that you're learning in grade 12, and it's a very important skill. Tumelo says, on the right track, last step, got me. Okay, good. Know where your mistakes are and fix them. You got to be able to differentiate, to do all the other stuff. Yes, I just want to make sure, before we move on, Primrose, I just want to make sure that we clear up any questions or confusion there might be, so that we don't keep on repeating the same mistake. So if anyone does have a question now, now's your chance. Please ask, don't be shy. If you don't want to ask in front of everyone, just DM us Coco, please. This is so important. This is such an important skill that we have to master. Okay, right. If at any stage you still have questions, then you're welcome to DM myself, or Miss Coco, or just raise your hand and ask. Everyone here are very nice people, so don't be shy to ask your question. Okay, so I've got 10 questions here. I don't know if we're going to get through them all in one go, but I think we must try to get as many as possible. So I think what we're going to do is we're going to do them 2 at a time. Check answer, 2 check answer. And then, yeah, so we'll do two minutes each, maybe 1.5 minutes. Hey, Miss Coco, how much time do you think we need per question? 1 minute or 2 minutes per question?
I would say maybe 2 minutes. Some of them are quite tricky.
Okay,
no, actually,
so 2 minutes per question.
1 minute is fine. 1 minute is fine.
1 minute, 1 minute. Okay, so 1 minute per question. And we're going to start with that first one. So we're going to check back at 17:43 for answers. In the meantime, please post them in the chat so that we can see who. Oh, Liam is off the mark already. Well done, Liam. Everyone else, please join in and practice your differentiation. There's 1 more minute left. I see lots of answers coming in. Just remember, guys, when you put your answer down, try and put it with the differentiation notation, which is f dash x equal, and then your differentiated answer. Okay, time is up. So we are going to have a look for question 1. We're going to differentiate. F dash x is minus 2x plus 3. We take the 2 times it by the minus 1, gives me minus 2. Take the 1 of the x times it by the 3, gives me 3. And then the minus 1 differentiated is just 0. Okay, now the next question, the notation is dy by dx. So when you give your answer, you have to write dy by dx, and then we differentiate. We are ready to differentiate because there are no roots, no fractions, no brackets. So 3 times 4 is 12x. Subtract 1 from the exponent, that'll make it a 12x squared. 2 times minus 2 gives me minus 4. X, subtract 1 from the exponent, gives me x to the power of 1. 1 times 5 is 5. Subtract 1 from the exponent, gives me x to the power of 0, which means that just goes to a 1 because x to the power of 0 is equal to 1. And 7 differentiated is 0. Awesome. I see quite a few answers here that are looking very, very good. So that's excellent, everybody. Okay, so that was round 1. So I think what we're going to do now, because we've got about 5 minutes left of the lesson. So I think what we're going to do is the remaining sums, I'm going to allocate it according to the initial in your name. Okay, so the name that is displaying in Zoom. So if it's Ashura, then it's A, Andiswa, A, etc. Okay, so I'm going to allocate according to your surname, which sum you must do. Okay, so it's with your first name, not your last name, your first name. That is going to determine which sum you must do. Okay, so for question 3, that's everyone with an A. We don't have any B's in the house, so we're going to skip right ahead to C. So if your name starts with C, like Chandra, then you do question 4. After that, if I look, the next letter of the alphabet is H. We don't have any C, D, E, or F's, but we do have H. So question 5 goes to the H's. I think Itumeleng and Jason, you guys can do 6 together. So I and J can do 6. Kiamogetswe, Kagelo, Golofelo, you guys can do question 7. So the K's do question 7. Then all the L's can do 8. And all the M's can do 9. And the O's and the P's can do 10. So O and P. And then let's see the R's. R's can go with L, I think. Question 8. R and L for question 8. And then the S's can all go with 7 as well. S and K. And then T. Let's put the T's with the M's. question 9. Okay, so off you go. You each have about 3 minutes to do your sum. So I think make it 17:51. We'll check back and we'll see if all the alphabet letters can agree on the right answer as well. Okay, so if you're wondering, the letters are on the board and you can see according to the initial of your name which sum you are doing. It's all on the board. Check back in about 3 minutes. Do your best. And then if you've done your own, you are welcome to choose any of the other ones because we're all going to go through all of them. So I hope if you are done, you can choose any other one to do until the time is up. Good job, everybody. Good job, Cassandra and Hope and Siso. If you are done, then choose any other one. Well done, Mhlali. We're going to see now if that's right. Good job, Primrose. I think those with the pies are probably a little bit tricky, but stick to the rule. The rule says just take the exponent of the x, multiply it by the coefficient, and remember pi is a number like any other. But I definitely think the m's, those who got question 9, you guys need to think the hardest probably. But again, don't get thrown off. Just follow the rule consistently. Okay, we've got 1 more minute left. Well done, Pelo. We're going to see if you're right. Pelo has given us question 9. Okay, time is up. Well done, everyone. I hope you, if you didn't post it in the chat, that you tried and that you made a good attempt. Let's kick off with question 3. So question 3 is in perfect shape for differentiating. No one posted an answer for 3. Where are my A's? Hey, those who were meant to do that one. Hey, and I think M and all the M's and the K's are going to definitely agree with me that you guys got an easier one than what they had, because question 3, no additional work needed. We can just differentiate. We're going to take the -2 times it by 1 gives me -2x to the power of -3. -1 times the -3 is a +3x to the power of -2. Differentiate the 5 and that's a 0. So that's the end of that. Okay, so A's, I hope you got that one right. Question 4, did anyone post an answer for question 4? Any of the C's? Yes, Cassandra did. Well done. Let's see. So we are going to take the half and multiply it by the 1 in front of the x. So that's going to be a half x, and subtract a 1. So that's -1/2. Then a half times minus 5 is plus 5 over 2. I see you got that one right, Cassandra. So subtract another one. That gives me negative 3 over 2. Well done. And then 2 over 3 times by 3, that just gives me a plus 2x. And then 2 over 3 minus 1 gives me minus 1 over 3. Well done there, Cassandra. You are definitely carrying the weight for the C's. Where are all the other C's? Okay, let's see question 5. I think some of the H's did post an answer for question 5. Did we see any 5s here? Yes, Hope. Well done. Hope was first actually with her answer. So F dash U, the U to the power of 2 will go to U to the power of minus 2. So that will be minus 6U to the power of minus 3. Well done, Hope. So far, so good. And then U to the power of a half will be the square root of U will be U to the power of a half. Times by 1 gives me a half U to the minus a half. Excellent work, Hope. That is correct. Excellent. Okay, so here's number 6, and Itumeleng has posted an answer for 6. Anyone else? Yes, Hope did 6 as well because she finished quickly. So well done, Hope. Yeah, that's it. Okay, so let's have a look at question 6. We are going to differentiate. This is going to change to 5 over 3. That will be a to the power of a half, and this will be a to the power of minus 1. So then we differentiate, and we go 5 over 3a. 5 over 3 minus 1. 5 over 3 minus 1 is 2 over 3. To the power of 2 over 3. A half times 4 is going to give me 2a to the power of minus a half. And then minus 1 times the minus 2 is going to give me plus 2a to the minus 2. Let's see. Question 6. All the I's. Who got that one right? Anyone? I thought I saw some people post answers for 6. Yes. Hope. Yeah, Hope's that's right. And Itumeleng, that's right as well. Okay, well done. Let's go to 7. Any S's posted an answer for question 7? Yes, well done, Sibisiso. Here's 7. So that's going to go k to the power of a half. We're going to change that to k to the power of a half. Don't get thrown by the root 5 because root 5 is just a constant number. So we can go a half times 4 is going to be 2k to the power of minus a half. And then for this term, we're going to go 1 times minus 3. And that's it. Siso.
Ma'am,
yeah.
can we have a look at that one again?
It's going to go to the minus a half.
K to the minus
it will be
a half,
minus
and then differentiate
2
that.
minus 3 over 2.
There we go. Yes, ma'am.
Okay, there we go. Minus 3 over 2.
Yeah.
Yes, there we go. So that is what you got as well. Excellent. Hope also posted for 7. Well done, Hope. That's right. Okay, let's have a look at 8. Question 8. Let me just move this thinking lady out the way here. Okay, anyone for question 8? I think I did see, yes, Liam. Liam posted for us for question 8. Okay, so we're going to go 2 times 3 over 4. This is going to go to t to the minus 1. And this will be t to the minus 2 over 3. Yeah. Okay, but let me write that maybe, so because there's a bit of work to do there. So 3 over 4 t squared. And then we go plus 2 over 3 t to the power of minus 1 to bring it up into the numerator, and then minus 9t to the power of minus 2 over 3. Okay, this is also a lucky one. If you got this one right, then you are definitely on track. So ds by dt is 2 times 3 over 4 gives me 3 over 2t. This is minus 2 over 3t minus 2, because we are subtracting 1 from the exponent. And then we go minus 2 over 3 times the minus 9, minus 2 over 3 times minus 9, so that I don't make a mistake. So that's plus 6t minus 2 over 3 minus 1 gives me minus 5 over 3. Okay. Here's my answer for that one, for question 8. Okay, so Liam, just check. I see you've got 3 over 2t. Yeah, just check the rest. So your last one must be to the power of minus 5 over 3, because when you change it, when you change this root, it goes to 2 over 3, and you're bringing it up, so it's minus 2 over 3. Okay, let's see, question 9. Mechlale posted for question 9 as well, so let's see if that one's right. Question 9. So that's going to be g of x is going to be root 2. And the x cubed is also being square rooted. So that's going to be x to the power of 3 over 2 plus x to the power of root 2. Okay, nothing we can do there with the root 2 power. You don't change that. If you want to change that to 2 to the power of a half, it's really not going to make your life any easier. So just leave it like that and differentiate it like that. So 3 over 2 times root 2 is going to give me, let's work it out on the calculator, root 2. And you can, by the way, leave everything in root form. You don't have to change it to decimals or anything like that. Just leave it in root form when you differentiate. Okay, so make sure before we differentiate, all variables, if they have a root, that you must change to a power. Okay, but numbers that are in root form do not need to change. They stay as they are. And then this is going to be 3 over 2 minus 1. And that is a half. Then we take this exponent, times it by the coefficient of the x, which is just 1. So it's going to be root 2x. And the exponent will be root 2 minus 1, because that's what the rule says. Take the exponent, times it by 1, subtract 1 from the exponent. Okay, I don't know if anyone tried that one. Yes, I see, Tumeleng, you did. So just have another look. I think you got your power right for the x, yes. But be careful of that root 2 there. I think it threw a lot of people off on what to do there. Okay, now let's look at this last question, question 10, with all the pi's. Okay, so again, pi is a constant, so don't let it throw you off, okay? So no roots here, no fractions. We can differentiate straight away. So dy by dx. And please take note of this example if you didn't know what to do with the pi's. So 2 times pi is 2 pi. And from the x, we subtract 1. So that's going to go x to the power of 0 is just 1. And then this one here, pi to the power of 3 is just, sorry, I skipped a term. Yes, sorry, I did skip a term. I got ahead of myself here. So 2 times pi, so that's going to be 2 minus 1. So that will be x to the power of 1. Then the next one, pi squared x. For there, we subtract 1 and we times by 1. So we just have a pi squared left. And then the last one, we differentiate, and that's equal to 0. Okay, so the last two were quite tricky. Did anyone give us an answer, Ms. Coco, for question 10? Did anyone try that one? Yes, so we've got 2 pi x plus 9 comma.
Primrose and Pielo did give us an answer.
Well done, Primrose. That is right. You can leave the pi squared as pi squared. You don't have to work it out as 9,87. So beautiful. Well done. Okay. I think we are out of time.
I'm going to have to cut us off, unfortunately, Miss Marlies. It's 3 minutes past 6.
Yes, but thanks everyone. Let's just say our goodbyes, Ms. Coco, and thanks everyone, and we'll see you back here on Thursday. Bye.